first goal is to rewrite one of the equations where it says either x equals something or y equals something. So which of these equations is going to be easier to rewrite in that way? Jack?
X minus y.
Okay, why? Why is that one the better one to do?
Because you can just take off the x.
Okay. Really, with this one, there's actually two choices. This one has y by itself, and this one has x by itself. Really, this one, y isn't a good choice because it is negative y. So if I get rid of the x, I'm not left with y, I'm left with negative y. So I could rewrite either of these. The main thing you're looking for is you're looking for a positive 1x or a positive 1y, because that means one step to solve it. Now, can you use the other one? Absolutely. If I wanted to solve this for x, I could technically take this equation right here, and I could solve it for x. I could say, okay, I'm going to subtract y, so I'd have 7x plus y. Don't write this down. This is messy. You can write this first part, but if I wanted to solve this for x, I could subtract y from both sides, and then I get 7x equals 5 minus y. And then I could divide by 7, and I end up with x equals 5/7 minus 1/7 y. Now, can anyone see why that's not the preferable way to do this? Maybe because it has big nasty fractions in it, and we don't necessarily want to work with big nasty fractions unless we really have to, right? So, my preferable way would be to deal with something that doesn't have a coefficient other than 1 beside, because that way I don't have to divide by something, which means I don't end up with fractions in my problem. Now, sometimes it might divide out evenly, but this time obviously it did not. So that's a big mess, and we really don't want to deal with that. So instead of doing that, I can take the same equation and I can subtract 7x from both sides. And that way I get y equals negative 7x plus 5, or 5 minus 7x. It's not slope-intercept form here, so it really doesn't matter whether we put our x term first or not. But either way, 5 minus 7x or negative 7x plus 5. Now I have one of my equations in either y equals or x equals form, right? Now, y equals that right there. So I'm going to take my other equation, x minus y equals 3, and I'm going to replace y with what y equals, which in this case is negative 7x plus 5. So taking this, I have x minus negative 7x plus 5. Now, one thing that can be easy to mess up here, those parentheses are important, because this is x minus all of y, and all of y is negative 7x and also positive 5. And before I drop the parentheses, what do I need to do? Distributive property. Now this one is probably a little trickier because you haven't done this in a while. If I have a minus sign right before parentheses, how do I do distributive property? Thomas? Right. This is minus 1 times that. So I'm going to multiply negative 1. And the nice thing about multiplying by negative 1, all it's going to do is change that to a, and change that to a. Okay, so if you have minus something in parentheses, all that's going to happen is you're going to change all the signs. So I end up with x plus 7x minus 5 equals 3. Now from there, I can combine like terms. X and 7x makes 8x. I started writing too big. All right, so then from there, I'm just going to come up here because I'm running out of room. So 8x minus 5, we're going to need to add 5 on both sides. And that gives me 8x equals 8. And if I divide through by 8 on both sides, that gives me x equals 1. So the first part of my solving gives me the value for x. And again, remember this is the hard part. Now the easy part is what follows. Once I find out what x is, I can plug it back in. And the easiest thing to plug it into is this right here because it's solved for y, and I want to know what y is, right? So I can plug x in. Negative 7 times 1. Negative 7 times 1 is negative 7. Plus 5 is negative 2, right? So let's write that down, though, just so we see. So negative 7 times 1 plus 5, oops, that's really messy, gives me negative 7 plus 5, which gives me negative 2. That's really messy. Anyway, so my y value is negative 2, my x value is 1, which means my ordered pair is 1, negative 2. All right, we're going to do one more together, and then I'm going to give you the remainder of time to work during class, and then I'll be walking around helping people. So we'll do one more together. So we need to put in that one into my Excel. Let's see, it's usually easier for me to do this from here. So 1, negative 2. Oh, that one's an easy one. Hang on. Okay, guys. Now this one actually still starts out fairly simple in the fact that they're in y equals form. So we don't even have to worry about putting the first one in y equals. Now it's not as easy as the last one because it's not y equals 7. It's y equals 8x minus 6 or y equals 10x minus 10. Okay? But I can take, since it's already in y equals form, I can take, say, this expression. So y equals 10x minus 10, and I can replace y in the other equation with 10x minus 10, right? So I end up with 10x minus 10 equals 8x minus 6. All right, so everyone follow where we got that so far? If y equals this, then that means this y equals that. So I can just replace that y, substitute. Remember, this is solving by substitution. So I can replace this y with that y value. So I get 10x minus 10 equals 8x minus 6. Now, I do have variables on both sides, so my first step should be put them on the same side. So I need to move the 8x over to the other side. So I'm going to subtract 8x from both sides. And I get 2x minus 10 equals negative 6. Don't forget that it's negative because we're subtracting it, right? So from there, then I'm going to add 10. So I get 2x equals positive 4. And then I'm going to divide by 2. And I get x equals 2. So there's the first part. Now the second part is plug x equals 2 into either one of those equations. They're both solved for y, so it should be easy to plug into either one. So which one do you want to use? The first one? All right. Y equals 10 times x, which is 2, minus 10. So that gives me 20 minus 10, which gives me 10. So my y equals 10. So I get x is 2, y is 10, and that's my solution. All right, so you guys have the remainder of time to work on level K, U.8. I'm thinking I'm probably going to set the SMART score still pretty low because they are a little time consuming, so I'm thinking like a 60 maybe. So I've got to finish working through it to see, but I'm thinking I'm going to let it be pretty low as long as everyone's working. Now, if people choose to goof off during class time, I may always bump it up. But I'm thinking for right now that I'll set it at 60. If you get there early, it's a good idea to do a few more, just to get the practice in. But, so if you're done during class time, I would rather you continue working to see how much further you can get. I may offer some bonus if you make it up to like 80. It'd be good to use that class time to get extra practice because, again, we have a test on Friday on this. And we still have one more kind.